Hello everyone, I have got a question. Let's see what is it. I just give you brief about that. This question comes from a particular topic called as biotechnology. In the terms of recombinant DNA technology, where the size of the DNA is given, restriction endonuclease sites are given. What you have to find out is the size of the fragment after the digestion with the REN, that is restriction endonuclease, and what would be the current representation when it comes to observe them in a gel agarose, or electrophoresis. Okay, so let's see first the question and then we'll go for that demand of the question. The question says 100 base pair DNA fragment was cloned between HIND3 and ECO-R1 site. So what is this fragment? Usually this fragment is called as insert. HIND3 and ECO-R1, these are nothing but recognition sites. What are the recognition site? Recognition site of restriction endonucleases, in common we call it REN. Okay, so the site is nothing but recognition site. On a DNA, they are the site or the place where this restriction endonuclease like HIND3 and ECO-R1 or NOT1 identify and cut the DNA into the pieces. Okay, so this is it. Further it says that of the plasmid vector PI80 of size 3500 base pair, what you can see here, they have written in a 3 point kb. Kb means kilo base. The clone fragment had not one site as shown in the figure. You can see this is the particular cloning DNA, or we can say that insert, which is of 1000 base pair, and in 1000 base pair that recognition site for N naught, or that not 1, was placed somewhere here. That means if this is the first base pair, and this is the 1000th one, then from 1 to 400 it is placed somewhere here. So this side, if we have 400 base pair, on the another side it will be having 600 base pair. Okay, now so whatever you are seeing is the insert. Okay, like that. Well, so this is the preliminary idea from the question. What else it says? It also says that to confirm the presence of the insert, that is this particular DNA or the alien DNA, the recombinant, not plasma, it's a plasmid, okay, was digested completely with 2 sets of digestion. Digestion is nothing but fragmentization of the DNA, is also called as digestion. Okay, so 2 sets of reaction. So in one we use only 2 restriction endonuclease, that is NOT1 and ECO-R1, and in the second set of digestion we use NOT1 and the HIND3. Okay, so though there are different type of restriction endonuclease, their site of recognition will be different, and hence they produce different size fragments, and the number of fragments will be produced, that depends upon number of restriction sites. Okay, now let us see. So this is the question. Now what is the demand? In a lane 1, you can see here lane 1 and lane 2. Lane 1 and lane 2 are nothing but the well in gel electrophoresis, where the fragmentized DNA will be loaded. Okay, will be loaded. So for A, lane 1, and for B, lane 2. So this is for A, this is for B, this is for A, this is for B, this is for A, this is for B. Now what you have to do, you have to identify, okay, the product of digestion is not 1 equivalent was loaded. In lane 2, the product, this one was loaded. Which one of the following correctly present the agarose gel electrophoresis? So you have to identify which among the 4. So basically from this question, what we have to do, how many fragments, what is the size of the fragment, you have to identify. Okay, now Well, so first we'll see what is the size of this particular recombinant DNA. Now, so the vector, that is the plasmid, is of what? Having 3500 base pair, and the insert is of 1000 base pair, which is making up what? 4500 base pair. So this particular DNA, after the insertion, it is called as rDNA, or you can say recombinant DNA. So recombinant DNA size is 4.5 kb or kilo base. Okay, now like that. Well, what are the recognition sites? So let us see how many recognition sites. Let us see. 1, 2, 3, 4 and 5. So total number of recognition site 5. Okay, what are those 5? So we have 3 recognition sites for NOT1 and 1 recognition site for EcoR1 and 1 recognition site for what? HIND3 restriction endonuclease. Okay, now, and hope it is clear. Now let us see the digestion. There are 2 type of digestion we have learned. What are those 2 digestion? So let us talk about the first digestion. So digestion A, which restriction endonuclease are used? So A uses or used NOT1 and, if I'm not wrong, EcoR1. Yes or no? So how many fragments will be produced? So number of fragments. So number of fragment, how we are going to find out? To find out that, let us have a little formula thing. Remember, to find out fragments, you must remember number of fragments is equal to number of recognition sites. Okay, now where in case of circular DNA, so what is a circular DNA? Say for example, this DNA has both the end joints. This DNA is called as what? Circular. So one cut will produce only 1. If 2 cut, will be producing what? 2, 1 and 2. So like that it is. Okay, you should remember. Or you can say circular DNA means where the ends are joint. Ends are what? Joint. Okay, the second thing what you should remember is the number of fragments are equal to number of recognition sites plus 1, where so when the DNA is linear means what? This is the linear, where ends are not joint. For example, if we have restriction 1, so how many fragment will you produce? 2. So 1 n is equal to 1 plus 1, so 2. If we have a 2 recognition site, So n is equal to 2, so number of fragment will be 2 plus 1. So 2 means what? 1, 2 and 3 fragment. So this is how it is. So you must remember that. Okay, number of fragment is equal to number of recognition site in case of what? Circular DNA. Okay, each cut will produce one fragment, but if the DNA is linear, the formula goes n is equal to n plus 1. In this case, n is equal to small n. Okay, now like that. Hope it is clear. Let us come back to our question. Okay, so number of fragments would be, in this case we have to just find out the recognition site of only these two. So let us see how many. This is the 1, echo r1 2, this is 3. Hind 3 it will not recognize. Why? Because the digestion we are doing only with the echo r1, not the hind. Okay, so that is why this will not be recognized. So 1 2 3 and this is what? 4. And though this DNA is a circular, hence the formula will be there, n is equal to n. That means capital N is equal to small n, or we can say number of fragments will produce 4. So what are these fragments? Let us see. So fragment 1. So first fragment will come from here to here. That means not 1 to echo r1. So let us see. Not 1 to echo r1 site, and the size would be how much? Given 500. So just write 500 base pair. Now the second fragment from, because insert is happening here, right? So second is echo r1 to this one, which is given how much? 400. So you just write it. So the second fragment will be of between echo r1 to not 1, and the size would be 400 base pair. Let us see third one. Third one will be not 3 to not 4. Why? Because hind will not be recognized. Why? Because we have not used such digest endonuclease. Okay, now like that. So what would be the size? So from not 1 to here hind 3 is 1100, and here it will be having what? 600, as we know that this insert is of 1000 base pair. So 1100 plus 600 will become 1700. So what is the third one? So the third fragment is from not 1 in the diagram, what I will label 3, to not 1, what we have identified as what? Fourth one. Okay, and the length will be 1100 plus 600, 1700 base pair. What about the fourth fragment? The fourth fragment between this knot to the knot 1, this one. That means this fourth recognition site to the first recognition site in this digestion. So again I will write knot 1 to knot 1 again, but the fourth fragment, which will be some 900 base pair. How it has come 1900? The total length of the DNA is 4500, right? So in this side how much is left? You see, so you just minus 500, then minus 400, minus 600, and minus 1100. If you do total, this will come some 2600. So you will get difference is what? 4500 minus 2600, you will get 9, and 3 minus 2 will be 1. So total 1900 base pair will come, whatever I have taken. Hope it is clear. So let us see. And you have learned from the class that in gel electrophoresis, smaller the fragment, far it goes. Heavier the fragment, less distance it run, right? So if we talk about the particular sequence, we'll find one which is the lighter will be occupying the first place, heavier will be occupying the second place, heavier than that will be occupying the third place, and the heaviest most will occupy the fourth place. Now if you compare this, don't you think it is happening matching with that? 400, 500, 1700 and 1900 base pair in digestion 1, where what is used? Eco R1 and not 1. Okay, so you can compare and you can see. Okay, just have a look, isn't it? Now in the same way, let us learn about the second digestion. Okay, so now we have learned about the digestion 1. Let us learn about the digestion 2. So now we have digestion 1. Now let us learn about digestion. Which digestion? Digestion B. With what are the restriction endonuclease? Again, not 1 but not eco R1, and what? Hind 3. So how many fragment will be produced? Let us see. So number of fragments will be equal to, let us see how many recognition site. So here in this case, let us see the number of recognition site. So it will be 1, 2, not this one, because here we are using hind 3, not the eco R1. So this will be 3, of course this will be the 4. In this case also the number of fragment will be 4, as there will be the 4 recognition site. Okay, now let us see what would be the fragment and the length of the fragment. Okay, so number of fragment 4. What are the fragment? Let us talk about the first one. The first fragment will be between n naught to this n naught, or not 1, not the eco R1. Okay, so 500 plus 400, it will be how much? Or just write it, not 1, 2, another not 1, that is second in the sequence, will be 500 plus 400, that is 900 base pairs. The second fragment between this not to hind 3, isn't it? So not 1 to recognition site of the hind 3, and the distance will be, here will be having how much? 600, isn't it? From 600 to this hind 3. So you just write 600 base pair. The third fragment will be of course from hind 3 recognition site to not 1, this recognition site. So just write it, hind 3 to not 1, the fourth one whatever we have labeled, and this distance is already given, 1100 base pair. And the fourth fragment will be again from here to here, what we have already previously found, minus 600 base pair, and what we have got, 1900 base pair. So you just write here, between not 1 to another not 1, that is what we have identified as the first recognition site, it will be 1900 base pair. Let us see the sequence. So we can say the lighter one will be going far, then this would be occupying second place, this would be occupying the third place, and this would be occupying what? The fourth place. Let us see the sequence. 600, 1, 900 base pair, second, 1100 base pair, third, and the fourth one is a 900. So option A is the correct according to the fragments we have got. Hope you have understood this concept. You can take a screenshot and come down to the class if you have a more doubt. Thank you.